Okay, this is part 2 of the video lecture for Math 140 for Tuesday, May 5th. And we're talking about ellipses today. And what I want to do in this part is consider 3 examples involving ellipses. The first example is, practice problem or example problem is to graph this ellipse. Okay. Well, what we can do here is note that 9 can be written as 3 squared. And 16 can be written as 4 squared. And then if we compare this to the standard form of an ellipse, which is x minus h, just to remind ourselves this equation, over y minus k squared, so x minus h squared over a squared plus y minus k squared over b squared equals 1. If we compare this general equation to the specific example, we can see that a is equal to 3, b is equal to 4, and the center is equal to, in this case, is equal to 1, 2, because we can identify 1 as h and 2 as k. And so now we can graph this. Let's create a graph of this ellipse. And we'll create some tick marks here. Could have done this in Desmos as well, but we'll just create a quick graph by hand. So you guys know how to do that. Our center is at 1, 2. That's our center. And then to create the graph horizontally, we're going to go 3 over. So we're going to end up, if we go 3 over, we end up right here. And if we go 3 to the left, we end up right here. Okay. Now vertically, we're going to go 4 up. So if we do that, we end up here. And we end up down here. And this looks like we have a vertically oriented ellipse. It looks something like this. Okay, so that's our ellipse. Not perfect, but it's a vertically oriented ellipse. And that's the first example problem. Okay, let's do another problem. Okay, in this problem, let's suppose we're given this equation, x squared plus 4y squared equals 16, which, by the way, is an ellipse. And in the first part, let's write this equation in standard form. Okay. And so to do that, the technique we use is we divide this whole equation by 16. So I get x squared over 16 plus 4y squared over 16. On the right, I get 16 over 16. Okay. Now let's simplify this equation. This simplifies to x squared over 16. Here we have a 4 divided by 16, so this gives us y squared over 4. And 16 divided by 16 is obviously 1. So this is what we get. And then as a final step, we're going to see if we can write the denominators as something squared, which we can. So we get x squared, 16 can be written as 4 squared. And 4 can be written as 2 squared. So this is what we get. And we've now written the equation in standard form for an ellipse. And that allows us to quickly identify the center. And hopefully you guys see the center actually is 0, 0, because we don't have any other terms here involved with x or y. So our center is 0, 0. A is equal to 4, and B is equal to 2. So that's our ellipse. And then what we can do in part B is graph this ellipse. So let's create a quick rough graph of this ellipse. I have to make sure to make these tick marks about the same, because otherwise what is an ellipse could start looking like a circle if the tick marks are stretched the wrong way. So in this case, our center is at 0, 0, right here. And our horizontal distance is 4, so we go out to 1, 2, 3, 4. We go 4 the other way, and we get out to here. Our vertical distance is 2, so here we are, 2 and 2, and we have a fairly stretched out ellipse, it looks something like this. That is our ellipse. Okay, it's fairly stretched out. It's a horizontally aligned ellipse. So this is another good practice problem. And then let's do a third practice problem together. Okay, in this third practice problem, we're going to sketch a graph of this equation. Okay, this is actually an ellipse written in polynomial form. And if you remember with circles, we did circles written in polynomial form. And then what we did is we rewrote those equations into the factored form of a circle, which enabled us to quickly identify the radius and the center, and then we could graph it. So we're basically going to follow the same approach here for this ellipse. We're going to try to write this ellipse even beyond the factored form. We're going to try to write it in standard form. Okay, and we're going to do that same way as we did with the circle. We're going to do this by completing the square, okay, in x and y. And so what I'm going to do is I'm going to rewrite this equation. I'm going to group all the x terms. So I get x squared plus 4x. I'm going to group all the y terms. We get 4y squared minus 8y. Okay. And then I'm going to move this minus 8 to the other side. So I get a positive 8. Okay. And then, as before, what I'm going to do is try to add something on to both of these terms to turn them into binomial squares, if you guys remember that technique. Now the difference here is I have a 4y squared minus 8y. So I'll take this step by step. I'm going to rewrite this equation as x plus 4x. I'm going to factor out the 4 here in front of the y. So I get 4 times y squared minus 2y equals 8. And then, as before, I'm going to try to add something on to turn these into binomial squares. So now I have x squared plus 4x plus something plus 4 times y squared minus 2y plus something equals 8 plus something. Now we have to add this something to the other side. We can add anything we feel like onto this side as long as we add the same thing onto the other side. Now we have to figure out what to add. And again, the procedure for doing this is take the coefficient in front of this middle term, divide it by 2. So 4 divided by 2 is 2, and then we square it. And so we're going to add on 2 squared here. Over here, we take the middle term, minus 2, divide by 2, we get minus 1. So over here, we're going to add on minus 1 squared. Now here we have to be careful, though. So here we're adding on 2 squared to this side, so we also have to add on 2 squared here. Now here, we're adding on minus 1 within the parentheses, minus 1 squared. But recall that we're multiplying what's in here by 4. So we're going to get in trouble if we just add on minus 1 squared here. We're actually adding on minus 1 squared times 4. So over here, we're going to add on 4 times minus 1 squared. And let's take this step by step. This gives us x squared plus 4x plus 4 plus 4 times y squared minus 2y plus 1. Because minus 1 squared is plus 1. And then over here we have 8 plus 4 plus 4 again. Okay, and this equals 16. All right, now we can factor these terms into binomial squares. And so we get x plus 2 squared. This is x plus 2 squared. If you're not sure about that, FOIL it out, and you'll get that. Plus 4 times y squared minus 1, y minus 1 squared. Okay, and this equals 16. All right. So now this is looking better. This is looking closer to what we want, but we still want to get this into the standard form. So now what I'm going to do is I'm going to divide both sides by 16. Okay, let's do that. We have enough room here to graph this. And if we do that, we get x squared, x plus 2 squared over 16. Now here we have a 4 over 16, so that gives us 1 over 4. Y minus 1 squared over, excuse me, is this going to, the last graph I had a different center, I think. Oh, okay. I was thinking this had the same center as a previous example problem, but it doesn't. Here we get 4, and then 16 divided by 16 is 1. Okay. The final step is to write the denominators in terms of something squared. And if we do that, we get x plus 2 squared over 4 squared plus y minus 1 squared. 4 can be written as 2 squared, and this all equals 1. Okay, so now I can see that my center, the center of this ellipse, is going to equal minus 2 and 1. We have a minus 2 because the general form has x minus h. Since we have a plus 2, that means the center must be minus 2 because 2 minuses make a plus. So our center is minus 2, 1, and A is equal to 4, and B is equal to 2. And so now what we can do is graph this ellipse. Okay, we'll put some tick marks here. Okay, we can place our center here is minus 2, 1. This is where our center is. And then we're going to go 4 over horizontally. So we go over to here. 4 over horizontally puts us here. We're going to go 2 vertically up. So we get 2 and we get 2. And we get this ellipse like this. Okay, that's our ellipse. It's a horizontally oriented ellipse. And that's the equation of our ellipse. So this was a third example problem, the hardest of the lot, where we had to actually complete the square in both x and y to find the standard form of the equation of our ellipse. In part 3, I'm going to talk about one more aspect of ellipses, which has to do with eccentricity and really the definition of an ellipse. So that'll be coming in a minute.